So in that case, so what is the difference between LDA and PCA, principal component analysis and linear discriminant analysis? Comparative analysis of principal component analysis and linear discriminant analysis. Both linear discriminant and principal component analysis are linear transformation techniques that are commonly used for dimensionality reduction. PCA can be described as an unsupervised algorithm since it ignores the class labels and its goals is to find the directions, the so-called principal components that maximize the variance in a data set. In contrast to PCA, LDA is supervised and computes the directions, linear discriminants that will represent the axis that maximize the separation between multiple classes. Although it might sound intuitive that LDA is superior to PCA for a multi-class classification task where the class labels are known, this might not always be the case. For example, the comparisons between classification accuracies for image recognition after using PCA or LDA show that PCA tends to outperform LDA if the number of samples per class is relatively small. So PCA versus LDA. So in practice, it's also not uncommon to use both LDA and PCA in combination. Example, PCA for dimensionality reduction followed by an LDA. Repeating PCA for dimensionality reduction followed by an LDA. In practice it's also not uncommon to use both LDA and PCA in combination. Example, PCA for dimensionality reduction followed by an LDA. So PCA, to put it in a simple component, PCA component axis that maximize the variance. You see that maximize the variance, whereas LDA maximizing the component axis for class separation. So that's what is our PCA and LDA.